So as we have seen so far, what are the different kinds of databases and what is a database and the characteristics of a DBMS database management system and applications of database management system. Now we'll go deep dive into again another concept in database called data abstraction. Okay. So now, as the name itself suggests, like abstraction, right? Abstraction is trying to hide something from the user. Okay. Now, for example, if you seen any database management system, like for example, if you have worked with earlier any a database like MySQL or DB2, you might have seen that it would be lot of like relational database. For example, you would see that there would be a table arranged in a rows and columns. Okay, behind the scene, or just behind that table, there is a lot of abstraction that is going on. What it means is there are a lot of internal irrelevant details that users are not exposed to, are hidden. Okay, so that the user just sees them as in a table and a row format. What I meant by those irrelevant or hidden information is that is nothing but your data abstraction. Okay, this particular process of hiding the irrelevant information or the details from the user who is accessing that DBMS is called as data abstraction. Now we'll see how there are different layers of it. Like if you observe, there is a physical layer, again view layer, and as well as logical layer to it. We'll get that one by one. So there are three levels of data abstraction in DBMS. So the very first one, if you see the diagram, right, this is how it looks. The at the top is something that you can able to view that. Okay, that is a view layer. There is a logical layer in between, and finally there is a physical layer. Now, what is meant by that? Each individual one. So the physical layer or the physical level of data abstraction is the lowest level of abstraction. Okay, that is that the bare minimum at the last, at the lowest level of the data abstraction. And what it says is how data is actually stored in your database. Okay, it talks about how data is actually stored. All right, there might be a complex data structure details at this level, like there might be a object class, object model. Again, deep dive into object oriented concepts where you have a class contains in itself the behavior pattern, which is called the methods, and there are attributes associated with it. Okay, with the class. Again, there are a complex way of representing a data structure, and that is happening at a physical layer. And then at a logical layer, which is the very middle layer, or at the middle between the view and the physical layer, is the logical layer. And this talks about what the data is stored in the database. Okay, the physical layer talks about how data is actually stored, whereas the logical layer talks about what kind of data is stored in the database. And the very last one, or the highest level of data abstraction, is the view layer. That is the layer that is exposed to you. Okay, that is the layer that the user interacts with the database. Okay, that is called as view layer. Now, just these are the different layers of data abstraction that we observe in database management system. And this is a pictorial representation, which means there is a physical layer, logical layer, and there are n number of views that can be generated or created out of those logical and physical layer, where physical layer talks about how the data is stored, logical layer talks about what kind of a data it has been stored, and view talks about how the user interprets or how the user interacts with that database management system. Now, a lot of times you might have come across a concept called schema. Okay, schema is very popular in database world, where schema is nothing but design. Okay, always remember the word schema is very much correlated to design. So, design of a database is called a schema. All right. So there are multiple types of schemas that are available. Again, this can be related to what you saw, the data abstraction, right? Physical layer, logical layer, and the view layer. In the same way, there is a physical schema, logical schema, and the view schema. We'll talk about that one by one. Now, the very first one is the physical layer or the physical schema, which happens at a physical level of the data abstraction. So the design of the database at the physical layer level of the data abstraction is called as a physical schema. And it talks about how the data is stored. Okay, that's what we saw, how the complex data structures can be utilized to store at a physical layer, and blocks of storage is described at this level. Now, at the same time, there is also called as a logical layer, logical schema, which happens at the logical level of the data abstraction. Again, this is a design of the database, how you are designing the database. And this logical schema, the programmers and the admin, which is the database admin, work at this level because they create this logical layer of logical schema at the logical level. The programmers and the database admins or database administrators, we call it as. Then the data, what's again important here is the internal details of how it is getting implemented and what are that, it's all hidden. That is the part of it. Okay, the data can be described as a certain type of data records that can be stored, but the internal details such as the implementation of the data structure is hidden at this level. It's not shown at the logical level, because that is again a part of your data abstraction that is happening at the logical level. And then finally, there is a view schema that is happening, or the design of the database that will happen at the view level. And view level is where the user interacts with the database, right? So in the same way, the view schema generally describes the end user interaction with the database systems. So always remember, the data abstraction is very much, you can compare and relate that to the design of the database, which is called as schema. Schemas can be of three types again: physical schema, logical schema, and the view schema. And view schema is where the user interface or the interaction happens with the database. Now, with that being said, there is understanding of this data abstraction and the schema, which is the designing of a database happens. We need to understand the instance of database. Now, as you know, if you take, for example, any database management system, like let's say there is a banking system, okay, banking database system, and this has got many customers who holds the account with a bank, maybe a savings account or the current account. Now, at a given point in time, maybe at January 1st, 2023, at 1 p.m., there is a certain instance of that database, which is there is a database of this banking system containing certain number of rows. Certain data is actually stored in the database. And with this in mind, let's take one example here. One example is, let's say a customer who is John Smith holds an account with a bank called ABC, and on that first first of Jan 2023 at 1 p.m., John Smith has his account balance of $4,000. Okay, but just a day later, it might be turned to $4,100 because he has deposited $100. Okay. But at that point in time, at the very moment of time, that 1st of January 2023 at 1 p.m., that moment of time, the data that is stored in the database is called the instance of the database. So, instance of the database is varying as the time varies. All right. So if on 1st of 1st there is a certain value that the database holds, on a day later there might be change in the database because of the certain transaction of withdrawal, deposition, all that happens across the bank. Okay, we are just taking one example of John Smith. There are so many Johns and Janes available who holds an account in that banking corporation. Okay, ABC, which we took as an example. So always remember that the data stored in a database at a particular moment of time, this is very crucial here, at the very particular moment of time is called instance of the database. So instance of the database always varies with the time. All right, understood guys, this one? And the next one is a database schema. Again, database schema defines the variable declarations in the table that belongs to a particular database. Again, as you know, instance is all about a data stored in a database at a particular moment of time, whereas database schema defines the variable declarations in the table that belongs to a particular database. Hence, the value of these variables at a moment of time is also an instance of database. Okay, so what it means is, now understand that we talked about schema is what it is, a design of the database. Okay, now when we say the design of the database, obviously we will say that in a database, let's say customer table, a database of banking system which has got a customer table, and customer table has got a particular entries or the columns in it. Okay, which is a customer ID, customer name, and the transaction type, and then there is a balance amount. Now these are all the variables, these are all the columns in a table, but they are actually the variables that are storing the values in it. The table contains a values for each every row that goes is a value containing in the database. So what it means is, the values of these variables at a given moment of time is nothing but instance of the database. That is what we saw in our example where we are saying John Smith has a account balance of $4,000 on 1/1/2023 at 1 p.m. Okay, but the very next day or the next month, that moment in time varies. So obviously the variables now contains a different values because of the lot of transactions happens during that month. Okay, the instance, that is what the instance of the database is. Okay, understood guys what instance is?
Yes, sir.
Okay, now database management system architecture. Okay, now what is this architecture? Database management system architecture. The database management system architecture, what it contains, as the name itself suggests, the architecture is about the components. Okay, what are the different components in the database and how they are related to each other. That is what we are going to define in a database management system architecture. So, DBMS architecture will help us understand the components of the database system and also the relationship among them. All right, like for example, a database management system might contain a number of tables. There might be 10 tables, 20 tables, 50 tables, and how are those tables related to each other, and in particular how are different columns related to each other. Okay, are there any constraints associated with them? Okay, like for example, if there is a key or there is a foreign key, we'll come to that what it is, but understand that there is certain relationship between the tables and between the databases, and how many set of tables exist in the database, all comprise of database architecture. Now, database architecture depends on the computer system that we are using, that we are running. Obviously, it varies from different systems. And what is it is basically a client server architecture, which means there is a client and there is a server. Client accesses and server responses, like which means client sends a request, whereas the server responses to that request. Okay, so the basic client server architecture is what comprise the database management system. All right, so now let's take this pictorial diagram and tell you different levels in that. All right, now here is what different types of architectures that we will talk about. Now, what are they? Single tier, two tier, and three tier. Okay, there are three ways or the three different types of database management system architecture. Now, always remember, why is it two tier, single tier, and three tier? We'll come to that now. Now, let's consider this single tier architecture. In this very architecture, right? So DBMS or the database is readily available on the client machine, which means the client itself has the database installed in its system. Like for example, the one very good example for the single tier architecture is when you have installed a database management system like MySQL on your local machine, and you are accessing the same database management system with the same machine. All right. So the same laptop or a desktop that you're working on is acting as a client as well as the server. All right. So database is readily available on the client machine. Any request made by the client doesn't require a network connection because you are having the database installed on the same machine itself. So you are working locally. So whenever you work locally on your database, that is what is a single tier architecture. All right. So any changes done here will directly be done on the database. It doesn't provide a handy tool for the users. Obviously, it is a development of local applications. All right. So always remember, tier one or single tier is the database is available on the client machine itself. That is one. Second thing is you only work locally with that single tier architecture where the development of the local applications happens on the same machine where the programmers can directly communicate with the database. Hence, because the database is available on the same machine that you are accessing, so the response will be very fast. All right, that is the advantage of single tier architecture. Now let's talk about two tier architecture. So the two tier architecture of the database management system, it has got a client as well as the server. So that is the reason it is a two tier. So now if you observe, there is a server which contains the database system. Okay, the database system is present at the server machine always, and there is also a client machine which contains the application. So this is a database management application, whereas this is a database itself. So database resides on the server, whereas the application through which you are accessing the database is on the server. Okay, that is on the client. All right. So there is a two tier architecture, and the two machines that are there, that is a client and the server, they are connected by a network. Network is nothing but you're trying to connect the two systems using Wi-Fi or a cabled connection, wired or wireless connection. All right, through the internet, or it might happen using a LAN, WAN, or any kind of a network that is exist between the client and the server. So always remember, in a two-tier architecture, there is a server and there is a client. The server always contains the database system, whereas the client contains the DBMS application, okay, through which the user accesses the database. And how can this access happens? It happens over the network connection. Now, let's talk about and how do we access that using a query language. Now, how does a application access? How does the user using the application accesses the database? Using the query language that is sent through the network, which means you are writing a SQL query. Like suppose I want to select all the columns from a table. So what command or the query it will be? Select star from the table customer. Okay, so it will select all the rows that are existing on the table customer. So accessing the client machine makes a request to access the database at the server using the query language like SQL. All right. So once the server receives the request, it responds back with the result to the client. That is what happens in a two-tier architecture. And how is that application is getting connected? The application connection interface called JDBC, which is one example of Java database connectivity, or open database connectivity of Microsoft. Okay, so these are the different APIs. JDBC is an API. Again, this is an interface application where it will help you to interact with the data. Okay, interface that makes it possible for the applications to access the data. So you connect that through a JDBC or ODBC. That is what we call it as Java database connectivity or open database connectivity. This is for Microsoft. Okay, like if you are using a Microsoft SQL server, you would be using the ODBC here. All right, it is nothing but it is an application connection interface. It is kind of a socket that is connecting the two. Okay, it is just linking the application and the data, and so that you can execute the queries and access from the table. Okay, it is simple. Like if you talk about, in if I give you an analogy, there is a water tank in your house, and at the top there is a big storage tank. Okay, now in order to access water from your storage tank to your local kitchen tank, you need to have a plumbing connection through the pipes you connected. So that pipe is nothing but your ODBC. And how are you connecting that is using the tap and everything that happens. It's kind of a ODBC is acting like that as a connection. Okay, nothing else. Now, three-tier architecture. So another layer is present in between the client and the server. So you saw the architecture here, the two-tier architecture, where you have a client server and there is a network connection that will happen, and they are able to communicate. The client is able to communicate with the server using ODBC or the JDBC. Now, in at the same time, in three-tier architecture, there is a client and there is a server and there is another layer that is present in between. That is the reason it is called three-tier architecture. And client application does not communicate directly with the database. It is the key here. Earlier, in two-tier architecture, there was a database management system application that was directly getting connected to the database system. But here, there is something in middle. Okay, and that is the reason the client application is not able to connect directly to the database. And what is that? What is that we are talking about here? It is nothing but there is also something called as application server. So there is a user, there is an application client. Application client will interact with the application server, and this application server in terms will interact with the database. This is one extra layer that is going to happen in the three-tier architecture. So what is that? Rather than the client application communicating with the server application, the server application internally communicates with the database. That is what will happen. So whenever the user requests the database management system client, this client will communicate with the application server, and this application server in terms will provide the connectivity to the database. Okay, this is about three-tier architecture. Now, so mind you guys, this is all about some theoretical concepts that you need to be well aware of before we try to venture into learning SQLs, because in order to understand SQL, you need to be in a frame of mind to comprehend what is a database, what is a schema, what is the instance of the database, what are different kinds of architecture layers that are there, and different models that we are going to see now, what is known as data models. So what is a data model? Data model are nothing but the conceptual tools. Okay, conceptual tools used to in the database management system to represent in a structured and organized manner. You are representing a data into a structured and organized manner. Like for example, you might have seen different kinds of data models like entity relationship diagram. Okay, that is one of the representation or the notation of the data models that you can utilize. Another is UML, Unified Modeling Language, where you have a class diagram and use it. We'll see that one by one, the example. But just to let you know, data models is a conceptual tool to represent the data in a structured and organized manner. Now, if you observe what happens here is, if I take one example of representing a data model, which is by ER model. ER is an entity relationship model. Now, as in the entity relationship model, there are three main components. Okay, one is called entity, one another is called attribute, and another is called relationship. Now, we'll see what is an entity. Entities are nothing but objects or the concepts that are representing the database. Like for example, customers are the entity, or orders or products. These are all the entities. So understand this from a point of view that at the very first beginning, that there is nothing existing in your application, that you are building it from scratch, and you know that you are currently working on a e-commerce website. You want to create an e-commerce website where buying and selling of goods happens. Now, in order to buy goods, there are customers. So you need to understand on a conceptual way what all the players that are existing in our application. So the customers will be there. There will be orders placed. There will be products that are listed in the catalog, and there will be a payments gateway that will be existing, and then there will be a tracking of the order. So all these are different kinds of entities or the objects that you can think of, okay, when you are creating a e-commerce sites. In the same way, if you are creating suppose you are creating a college management system, okay, or the school management system. So in that college management system, right, there are many entities involved. One is students entity, courses are there, department is there, fees is there, staff are there. So all these are different entities, and again these entities have got certain properties. Those are nothing but attributes, and these attributes or properties are the characteristics of entities. Like for example, customer is there, is an entity. Customer might contain a customer name, okay, they might contain a customer ID, the address of the customer, or the location of the customer, okay, the pin code of the customer, the mobile number of the customer, email ID of the customer. All these forms the attributes, okay. These are the properties or the characteristics of these entity. In the same way, if there is an order might have an order date, okay. Order date is one of the attributes. Then the number of orders, okay, order delivery date, okay, tentative date. So all that comes as a part of the order entity. And again, products might have a product price, product title, then product color, product weight, and again, depending on the kind of a product size. If it is a garments, then it is a size involved, color is involved, material is involved, whether it is a cotton, nylon, or polythene. So all that forms a attributes that defines the product. All right. Then there is a relationship. Relationship is nothing but the association or the connection between the entities. So there are entities, customers is there, products is there. Then what is the relationship? A customer can buy products, okay. So the customer can buy many products, or many products can be bought by customer. There is a relationship, and customer can buy a product, and when the product is bought, then there is orders created, okay. Then there is a relationship between product and order. All right. So this kind of a relationship that exists between the entities is called as relationship. All right. So the relationship between customer and orders, product and suppliers, etc., they all forms a kind of a relationship. That is the reason it is a ER. ER model is a entity relationship model. Entity is an object or the concept. Entities can have a properties which are nothing but attributes, and the relationship is the relationship or the association or the connection that exists between the multiple entities. All right, understood, guys? This one ER diagram of for the data modeling, how the ER model works for data modeling components. Because if we talk about this one, right, you will be able to understand how this is related to ER. Now if you observe this diagram, this is about a project management example here. So now what it contains, there are programs, there is a WBS is a work breakdown structure, there is a projects, there are project roles, all these are called entities. Okay, then what is the status of the project, what are the activities that are involved in a project, and how many people, and what are they working on, what are the departments they are associated with, and if there are departments, then how many number of departments are there and the IDs associated with it. Okay, these are all are called as entities. Okay, now entities will contain these attributes, like program might contain a program ID, a program name, or a manager ID who is managing that program, and then there is a status, whether it is a open, closed, or in progress. So that is the status. Now this is about a software development life cycle. Okay, it is for basically for SDLC. This particular diagram is created so that you can track the different programs, and these programs contains different projects, and these projects contains different activities. Okay, and the WBS. All right, so like for example, I suppose there is a software development team. Okay, and they are currently working on building a social networking site. Okay, like for example, LinkedIn or Instagram, they're trying to build a social networking site. Now in that social networking site, a lot of things comes into play. Okay, there are social networking posts are there, there is a user, they are there, and how the user interacts with the other users by posting, liking, sharing, all that happens. All right, now you are creating that particular social networking website. Now in order to create that social networking website, there are lot of members involved in the team. There is a UI team, which will UI UX team, which will talk about user interface and design, and there is a database team, there is a application web development team, there is a mobile app team. So all these teams are existing in order to run that program of developing a social networking site. And this major program is divided into multiple projects. One project is related to creating a database. Okay, maintaining and creating a database. Another program project is working on user interface and the front end development, and there is another uh, project that is working on back end development, and there are multiple teams that are involved in each projects. Okay, now the project might contain a project manager, project developer, the tester, and those are the project roles. All right, and then there are teams. For each role, there is a team associated with it. Like for example, project role ID. Let's say he's a developer, and this developer is a person, and they are developing from certain time to time. Okay, they are working on a certain task, and their name, details of that person who is working on. So in this way, you are trying to create a diagram here, entity relationship diagram, in order to develop a application related to this project management. Okay, this is the actual application that you are trying to build, a database for a project management software, like a Jira or anything you see these days. Those can be built using the diagram that is shown here. A program, work, WBS, work breakdown structure, the activities, and all that. Understood, guys? What goes into thinking, creating the diagrams?
Yes, sir.
And now, in the same way, like we have a data modeling for diagrams, you can also use the UML diagrams as well. UML stands for Unified Modeling Language. They are closely associated, or one of the representations or the notations that you can use for data modeling. Now, what is the main catch here for UML? It is the class diagram. Like you create a diagram for entity relationship model. In the same way, for UML you create a class diagrams. Classes, like you already know, these classes are equivalent to the entity. Like if you are comparing the UML with the diagram, then the entity that you see in the diagram is closely related to classes, okay, in the UML. And at the same time, attributes, what you see are the attributes or the characteristics or the properties that define the classes. And then there are methods. Methods are nothing but the actions, okay. They are the specific representation of the behavior or the actions that are there in the class. And then there is a relationship, how the relationship between the classes and objects, you will be able to see UML diagram. Now one example here is a customer is a class, and this customer contains a variable called name, which is of a string data type. And then there is a address variable, okay. These are the two attributes. These variables are nothing but the attributes, okay. And this customer is a class, which is same as the entity in diagram. And then there is a order class. Order class contains two attributes here, which is the date and the status. Date is of a data type, and status is of a string data type. And then there are certain methods here, which what are those methods? Methods are nothing but these are the functions. These are the methods inside the class. And what they do, they talk about the behavior of the certain methods or functions. So what it does, calculate subtotal, calculate the tax, calculate the total, and then total weight of the order. So all these are the methods or the functions that can be used inside the class. Class is order. In the same way, there is a order detail, item, payment, cash, check, credit. All these are the classes, and they contains the attributes, and then these are the methods. Okay, what you see here, a function, right? These are nothing but methods. All right. This is also a way to do a data modeling, like the way we do diagram. There is also a way we can do it by UML diagram. Now, next thing is called as a data dictionary. As you know, the data dictionary is in the tabular format, which is like a table-like structure. It contains what are the data sets or tables, which contains the columns or the attributes. All right, and what data type that column is, and description of that, and other details. Like for example, if you see this observation here, this is a name. These are all the columns that are there in the table or a data set. Okay, table or the data set. You might have a column called business entity, which is of an integer data type, and some description of what this data column name is. Okay, column is nothing but attribute. And then there is a person type, which is a character representation, and name style, which is a bit representation, either true or false, 1 or 0. And then there is a title, which is a character representation with 8 characters, first name, middle name, last name. All these columns are the attributes that are defined. Okay, now this is a primary key, this is a foreign key. You can also talk about these constraints as well inside the data dictionary. This is also another way of data modeling. What you are trying to do, you are trying to create a database table which contains all the attributes, a data set or the table which contains the columns and the description, which are nothing but the attributes associated with that table. Okay, this is again another way of doing a data modeling using data dictionary. And there is a last one now is related to data flow diagrams. So I normally call it as a DFDs. And data flow diagrams is mapping out the flow of information. It is all about flow of information from any process to the system. Like just take this example here. Now, this is a good representation of data flow diagram. What it is, a user, when he orders, there is a process order, and what happens if the billing information is given, then the invoice is generated. And the other one, the order information, then orders, what are the orders that are there. Okay, and then there is a shipping information and where you want to ship the products, the address and everything. All right, it goes ship the products, and then you are get the user would receive the product. Okay, and there is another way, the user orders, it processes the order, then you enter the all the billing information, the invoice is generated, and this invoice containing the billing information, you will also collect the payments at this point in time. Once the payment is collected, the invoice statement and everything is sent to the user. This is what is happening here. It is showing you how the flow of information is happening among the different components or the processes or the systems. Okay, there is a user, there is an invoice generation, there is a payment, and again there is a order validation, then you are sending the shipping the products, and then the fulfillment of the product happens, which is fulfillment is basically you have a warehouse, and warehouse contains that products, then collect that product and ship to the user. Okay, this is what we call it as data flow diagrams. All right, this is also a way you can get lot of insights about how to create your database. All right, so this will data modeling always helps you to design your database in different formats using either entity relationship diagram or UML diagrams or DFDs, which is data flow diagrams, and also data dictionaries. All right. So data dictionary, right? It is not whole single you can use it. You can combine a data dictionary with ER diagram. Okay, take this data dictionary along with the ER diagram, and that will be helping you to create a better data modeling for your database. Okay, so understood guys, this one, how the different kinds of data models exist, and that will help you to create using a different notations or representations of data modeling. Now, with that being said, let's talk about different kinds of databases that utilizes these models. Now, what we you have seen is data models. Now you are going to see a different databases. All right. One is hierarchical database, network database, relational database, then there is a entity relationship model database, and the object oriented data model database as well. Now we'll take one by one. As the name suggests, hierarchical database, it is basically a tree like structure, hierarchy. So there is certain top node, then there are a couple of nodes, and that nodes contains again multiple nodes, and this is nothing but the hierarchical representation of a database. Now, in this hierarchical representation, either you go top to bottom or bottom up format, that is up to you. But one a key point here is it always have a parent-child relationship. A parent can have multiple childs, but a child can only have a single parent. Okay, the child can have only one parent. That is the hierarchical database. The best example you can see is IBM Information Management System. This is the database system that is utilizing the hierarchical database. Now, this is a pictorial representation. So here, college is at the top. Okay, this is a parent. It contains two children. College can have a department and also infrastructure like library, auditorium, and all that. And then this department in turn can have courses, it can have teachers or the staff, and it can have the students. Okay. And again, the courses can have a theoretical part as well as a practical part in the labs. All right. Now, if you observe, a parent is having multiple children, but no children is having more than one parent. Okay. Theory is having one parent, which is course. Teachers is having one parent, which is department. Department is having one parent, which is college. So that is a hierarchical database representation. Okay. The best example is IBM Information Management System, IBM IMS. This DBMS system utilizes the hierarchical database model. Then there is also another database called network database. Network database is allows each child to have multiple parents, which was not the case in hierarchy. Hierarchy has only one parent for a child. Here, a child can have multiple parents. All right. So now the best example for this is, if you see, Ingress database, Torbol image, UNIVAC DMS 1100. All these databases management system utilize the network database. Okay. So if you help to address the need to model more complex relationships, okay, many to many relationship, that is when you are going to use network database. Why many to many relationship? Because a child can have multiple parents, right? Like the way if you see here, a college can have department as well as library, and library can have students. All right. And even the department can also have students. All right. Now students has got two parents. All right. This is called a network database model. All right. And the next one is a relational database. This is very often used. Okay. This is the most popular relational database. Even when we are learning SQL, this is what we are going to talk about: relational database. Relational database is the most widely used database management system, and what it contains, it is always the data arranged in the rows and columns in the in the form of tables. All right. Relational database contains the rows and tables in the rows and columns of the table format, and they can modify or change using a query language called SQL. So SQL is the query language that we are going to use in order to manipulate, insert, change, modify, delete, alter, everything we are going to do using SQL query language in the RDBMS, which is a relational database management system. This is what is a relational database management system. The best examples are the popular ones you saw: MySQL, IBM DB2, Oracle, Microsoft SQL Server. All these are relational databases. All right. So now if you observe this relational database structure, right? Now, if you see, the very top one is called the columns, and these columns are nothing but attributes. Okay, they don't have any order, they are just arranged, and this order contains values. Each column contains a value. Like first name might contain Ravi, Pooja, or all these names will be there. Lavanya, Vittal, everything will come here. All right, names. These contains a column name, which is nothing but an attribute, and it contains values for each entry into a table row. Now, this is also called a header. Okay, the entire thing is called a header, and these individual rows are called, these are called horizontal, these are entries are called rows or tuples. Okay, they are also unordered, and this entire thing is called the body. All the rows are called the body, and this is entire thing is a relational table. Okay, it is a relation table. All right. This is how you are going to see in a relational database management system that we are going to talk about throughout the course of learning SQL. And there is an entity relationship database. Again, it is related to entity, attribute, and the relationship. Okay, it replicates the real world scenarios. Like a customer might have a customer ID, customer name, customer address, and all that is related to the real life scenarios. Now, if you observe this one example, okay, what it contains, these are representing entity, and the this shape is representing action, and attributes are represented in a oval shape maroon color, which contains what, suppose an entity customer contains name, address, email id. Okay, these are all the attributes of the customer. Again, there is an item. Item is an entity, it contains a name and a price. The company is an entity, it contains a company name and company. And there is a order. The order entity contains an attribute called order number. All right. And what it contains, customer orders the items. This is the relationship that you're saying. So this is an action. Customer orders the item, whereas company produces the items. All right. And item contains in the shipping cart, so the shipping cart contains this item or not. All right, this is how the relationship is read in the relationship diagrams. All right. And this is another example as well, just to reference, I'll share this with you as well. And the very last one is object oriented database, as the object oriented is very closely related to the object oriented programming. All right. Object oriented programming, for the time being, I know we have not went through it so far. In other programming languages like JavaScript and Python, when we venture into, we'll go deep dive and understand what is meant by object oriented programming. But for now, just understand that object oriented database is related to object oriented programming, and how the data is represented as objects. So every object is a representation of a data, okay, with attributes and methods, obviously, which is involved. That is what it is, a object oriented database. So very complex data structures are using this kind of database, like in terms of scientific research, engineering, and multimedia, you usually use object oriented programming databases. Some examples are object store, cache, or ZODB, and objectivity. These are all the examples of object oriented database management systems. All right.